All right, here in section 8.3, we're going to be simplifying radical expressions. And this first rule that I want to show you is the product rule for radicals. And basically, in a nutshell, we can multiply two radicals together. This is a radical, and this is a radical. The only prerequisite that must be true is that see how both of the ends are true? Okay. That needs to always be true if we are going to multiply two radicals together. So as long as our root is the same, then we're going to be fine. So let's go ahead and do some examples here, and it's pretty simple. You just kind of multiply them together, and then you're done there. Okay. So for example, right here we have square root of 5 times the square root of 13. Well, they both have a ghostly 2 right here, right? As long as they both have a 2 right there, you can multiply those two guys together. So we could just go ahead and do 5 and 13, which is a square root of 65. And that's about it. You say, what? That's it? That's it. No way. Yeah, I'm telling you, that's it. All right. And going right here, see right here, also if we're going to multiply radical 7 times radical xy, then that's the same thing as saying the square root of 7xy. That's it. Now, notice right here I said that each radical has to have the same index. Now, that's just a nerdy word for what this little 2 is right here. The index is the number that goes right here. Okay, this is just some nerdy stuff. I mean, really, you don't need to indicate that definitions, but just so you know, these little small numbers are called the index. And if you want to know the number that's inside or underneath the radical, it's called the radicand. So these are like xy would be known as the radicand, 7 is the radicand, and this 2 right here is the index. But cool beans. Let's just go ahead and move on to example number 2. It's very, very similar there, and that is that we could also divide radicals, and a fancy way of saying divide is quotient. So if I have the nth root of a over b, well, that means I can take the nth root of a and the nth root of b. Okay, so it's kind of neat right there. So watch how this works as well. Coming down over here, notice that they both have a 3. So since they both have an index of 3, then I know that's going to be the third root of, and then we just multiply 2 and 7 and get 14. Okay, coming right here. Again, they both have an index of 6, so I could say the 6th root of 8 times 2 is 16, and r squared times r to the power of 3. Remember that we just add them, right? So r to the power of 5 right there. Okay, but just one thing real quick though. For something like this though, you don't want to leave it as the 6th root of 16. You actually want to probably simplify something like that. If it is if you can't simplify it, meaning if you can simplify the 6th root of 16, then do that. Like say if this was a 2, then you would simplify that. But third root of 14, there is no one number that you multiply by itself 3 times and get 14. And neither is the same thing with there. Okay, so just when we get to problems like that, we're going to want to go ahead and simplify them. All right, look at a number or letter C and D now. So they both have an index of 5. So we have the 5th roots of, and we just multiply 9 and 8, gives us 72. And y squared times y squared, remember that's going to be y to the power of 4. We're just doing our rules of exponents, and x times x, that's going to be x squared, and that will be that dude right there. And last but not least, letter D. Let's see here. So this is the square root of 7, and this is the cube root of 5. So this index is 2 and this index is 3. So since they do not have the same index, you can't simplify this. Our answer is just this. There's nothing that you can do to simplify it.